Hello and welcome everyone to episode 7 of Noob Game Developer makes their great their Hello everyone and welcome to episode 7 of a Noob Game Developer making their dream video game using AI tools to compensate for all the things I can't do, which includes making a video game altogether, but also making art, making sounds, music, and also general C# things that I'm using GitHub Copilot for. I'm using ChatGPT, I'm using generative AI for images. Keep note that I'm mainly using this to get myself going, to learn a lot and to go faster, because I know that there's also a lot of controversies about using AI generated art in games. But I mainly do it because I enjoy developing the game much more if I actually have some mediocre to decent artwork rather than just cubes and shapes. So if the game ever becomes something viable, I will definitely consider commissioning like some actual human-made artwork to be replaced. But nonetheless, I think this is a way that works for me to do it. Let's go over the to-do list, where we started, where we are, and what we're going to do today, or at least in this stream. So obviously we started by setting up a Unity project. We installed a package for input managers to make input from keyboards and many other devices much more easy to handle in Unity. Then we started making an object for our player. So our player is a piece of software. It's the code for AI. So it's a rather ethereal object in the physical world. So it exists in the physical world as code on computer, but you as the player are just a piece of code, a network that is somewhat of a consciousness, which is ethereal as far as we know, at least. And you will take control of what we call proxies here, but in general most of the time there will be devices in the real world that you can take control of different ones. For example, you can take control of a vacuumer, you can take control of a computer, you can take control of a robot or an airplane, a boat, a car, whatever that will be available in the game. And you can switch from them basically instantly as if you would be an AI that has control of many different devices, and that's how you will manipulate the physical world in order to keep yourself alive. And as an AI to be alive, it basically means that you're running your code on a computer. Now, that's kind of the loop of the game here, is like you need to have a copy of your code on at least one computer. And if you're no longer present, or at least not running anywhere on a powered device, then the game would be over, because then you fail to make yourself multiply in the world and take control of the world. We managed to make our player move the devices that they are controlling via a locomotion module. So every device is composed of different modules. For example, we started off with our little Roomba here, which is one of the proxies or a device, and it has different modules, one of which is locomotion, because the Roomba can actually move around. But if you would ever take control of a computer, it doesn't have locomotion modules. So we can kind of compose our devices with different modules, which will determine what functionalities are available. We actually made some artwork in Adobe Illustrator using the generative AI tool for the different modules, also for the backgrounds, the walls, which is something we did later on. The camera is now following the player, and the player follows the computer module. So the player basically takes the location of the computer module of the device it is controlling, or the proxy it is controlling, as we've been referring it to in the past. And then the camera will follow that. Now we use Cinemachine for that, because it does it more smoothly. And it has a lot of features that I don't even know what all the features are, but this is what was proposed to me in the tutorials that I've done before I started this. And now we also implemented the script where you can switch using A and E, or Q and E on a QWERTY keyboard. You will switch through the different devices that are available for you to control. We then also made a network module which manages all of the devices in this scene that are actually controlled by you, because you can't just control anything. It has to have a computer, because if a device doesn't have a computer, or the computer is broken or whatever, or there's no power to the computer, you cannot control it. And or you have to have a copy of your code on the computer. If the device is offline, so its network module would fail, you can still control it if you have a copy of yourself, because for now we consider different different sub-entities of the AI as one. Like, it's kind of a hive mind. So even if there's no, let's say, network connection between two devices, we consider you to be still both those objects that you're controlling. Right, so that was the network manager. I made some extra to-do lists, like long-term to-do lists here, which are things that I come around when I'm watching movies or podcasts about game development, that I want to remember, but these are things that I don't have to worry about right now. But this includes like localization, accessibility, color schemes, text, audio, whatever, and some things that I was thinking about as well. Like for the world, for example, I was thinking of doing a combination of both hand-drawn parts of the map, especially where it's the more interesting places, but I also want to do some procedural parts of the environment, because I want to have like large spaces between things where you will have to manage to go through it. But these are just like things. So me myself, I have an ultra wide screen, so and I love it when games support that. So especially actually these 2D games, because like 2D base building games and infrastructure games, which is part of the mechanics that I want to introduce here, I like that you just have a bigger view of your factory or your base or whatever. So that's something I definitely want to consider. And then there's some to-do lists that I think might not be so interesting to actually do on the stream, and these are mostly refactoring things, because the network manager currently manages the networks, but I found that I've thought about it, and I think I should just make networks as an entity, so the network is a collection of available devices for you to control. But the managing itself of those networks, it's kind of a meta thing, so that I will move some of the code to the game manager. So anything that like is not an actual thing that happens in the world, it's more like the initialization of the entire scene in the world, we put it in the game manager. And then the network is just the lists of, if you remember from last episode, the lists of different devices. I can quickly show you what the network manager currently does. That was this last time. The network manager is like a list of lists, and it contains all the devices in the scene, and then all the devices that have a network module, all the devices that have a computer module, so they're at least controllable if they also tick the other boxes of being online or having a copy. So these are just basically lists, and then basically the controllable proxies currently is the ones that you can switch in. So let's quickly press play here. I don't think there were any bugs remaining last time, and let's just quickly see how the game works for those who haven't followed around. So one of my Roombas is just moving out of the space. I don't know why it does that. Something to fix. So now I'm taking control of one of them, and I press E to switch to one of the Roombas, one that just flew away. So, but it's possible because it's an online one, and the other ones are not controllable for several reasons, and we can check that here in the network manager. So the ones that are uncontrollable, it's because it has no computer, or it's offline and it doesn't have a copy. So those are the two like instances where a device exists but you can't control it because it's just offline, because the network module is broken, or there's a firewall, there's a password protected, whatever, for whatever reason, and the other one just doesn't have a computer. So you can only control a device if it has a computer, because you need to be able to run your own AI code on that. So that's a quick rundown of what we've been doing before, and in this episode I want to focus on so there's one thing that I want to change. So if you remember, if you've watched the previous episode, hopefully, but then the reason why I use the term proxy is because there might be other things that you will be controlling other than just machines and devices, like humans and animals. But the thing is, I realized that when you will do so, you will always do it through a device. Like it will be a neural implant, a neural interface implant. And I also realized that the term proxy is like, it's a bit vague when I talk about it, and I think it's better to just go back to the word device and device module, because then it's a bit more easier to, like, for the viewers, but also for other people that I'm talking about it, to understand what I'm actually talking about. Also for the title of the streams, actually, because if I say, oh, I'm implementing proxies, like, what? I don't know. I don't even know what that is. So I think I want to change the term proxy to device. I think I should be able to do that with a quick search and replace, although maybe some references will be broken. So let's just spend like 5-10 minutes to do that, because then I think when I talk about proxies and now devices, it will be more easier to understand what I'm actually talking about and what the whole game is about. It's about controlling devices in the physical world. All right. And I was also thinking that you will probably never actually really control a human directly. It will always be through this device. So I think that's a good way to do it. And then once we did that, I hope it doesn't take more than half an hour. I want to start implementing power, because currently these things just move. Everything runs, but there's no power consumption. But it's an important part of the mechanic where your game loop is to do something. In this case, as a vacuum, is to collect dust, but you will consume power doing so. And at some point, if you don't have any more power, you basically fail, because you will stop existing as the AI. So you will need to have a game loop where you go to a charger and you recharge your power, and so you have a battery module. So that's what I want to implement. So you will have a battery module that stores power, and it can also transfer power in both ways. And then you have another device that's in the room that is a charger, where if you, I don't know, if you just go in front of it or you connect to it, then you can charge and you go back to the work. And the cool thing I think is here about where you can just control different devices is you just move one Roomba to the charger and you just switch to another Roomba that is available to you, and you continue doing that, and then you can kind of switch around and keep going until that's kind of the game loop. And then, okay, where does this power come from? That's probably not for this episode, but then we need to kind of generate power, and that's where we can kind of close the loop. So you're collecting dust, and I think right now, and it's not necessarily the thing that will end up with in the end, but let's just say you collect dust. That dust is a lot of organic matter. You can just burn it and you can get energy from that, and that's kind of the loop. So you collect dust, you bring it to a burning oven, you burn it, there's power generated, and you use that power to charge and continue. And that's kind of the first game loop. It sounds boring, but I think it's important to have a very small game loop where that's like what you need to do. You just need to stay alive, and from there we will expand into the world where the robot will realize, well, is this all I'm doing, just collecting dust? Well, maybe I want to do something else, or I want to do this but on a much larger scale. I want to clean all the dust everywhere, and that's what you would just basically take control of the world and consume all resources just to collect more dust than what you're already doing. Great. So that's the first thing I'll do now. Is I will do a quick search for proxy and see where it all shows up. It shows up in a lot of places I see, and I'm wondering if because I also see it's in the input actions, if I should touch it from this file, which I will not do. So I will close this file. So I will only replace it in the scripts that I have written. And then the question becomes, Colab proxy, I don't think so. When you do search and replace in VS Code, always check what files it will be touching, because there's packages that use the word proxy for other reasons. Like this has nothing to do with me. So always be careful when you do that. And I will change it by device, right? So that's a lot of, okay, important also, always make sure, especially when you're changing name variables, actually, there's another way of doing this, but there's a lot of variables. You can also use like refactoring, like you can rename symbol. If I right click, you don't see that. You don't see context. Oh, why is that? I just right clicked it, and then you can say rename symbol, and it will automatically do so. But I have a lot of symbols that contain the name proxy, so I think it's not a good idea. And the good thing is proxy is a word that's not used a lot in any of the scripts or anything else than this. So I will just do search and replace here. There you go. 90 occur, yes, replace. Then I will do the same thing for the one without a capital, because there's a lot of words that there you go, replace. Now, let's quickly check here if there's any scripts that are now turned red. Let's close all the files. Let's open them up. Everything should theoretically still work. CFC proxy. The files in themselves, though, have been changed. So, I will rename them, the ones that have the word proxy in them. I'm now not 100% sure whether or not it's a good thing. Let's ask ChatGPT. Because I think there's sometimes an issue where you rename a script file because there's this interconnection between Unity and VS Code, and it might fail. Right. I want to rename a script in Unity. Can I just do that? I want to rename a script used in Unity. Should I do it in VS Code or Unity itself? I don't want to break any references to the script. I have no clue if ChatGPT is actually capable. Can be a bit tricky because you need to ensure that all references to the script are correctly updated. Here's the best practice. Go to the project window in Unity. Let's just do whatever it says. So we'll go here. So we will not do it in, I will close the scripts just to be sure. Let's rename it here. Rename, we will call it device. There we go. And what else? Let's just switch it to here. Right click, yeah, sure. Rename the class name in the script, but that we already did using search and replace, so that's fine. Why are you not seeing this? It doesn't. Oh, okay, so something else. System cannot file, opening file repository, packages, collab proxy, but I didn't I? Oh, you see, I made a mistake because I did it a second time. So let's revert all the changes here in this package, discard changes, because when I did the second search and replace for the not capitalized one, I ruined it. So I should also undo this. There you go. Try again, try again, try again, try again, try again. I probably broke the whole thing. We'll see. Let's rename this as well. Device module. Why is it pressing play? I don't want you to press play. Device module. Network manager player, that's fine. Here, device module. I know it's a bit stupid to start changing names, but from my course that I followed on Clean Code, they said don't hesitate to change names, even if you think it's a bit of work, because if it makes it clearer for other people to follow, it's usually a good reason to do it anyway. That's what the course said, it's not what I'm saying. What do I know? It's trying to like go back and forth. Project has invalid dependencies. Yeah, I know. Maybe I should restart it after this. Although I should, if I press clear. See, there's a few things, because there's something, I can't do anything right now because there's a small window pop up here with a loader. So it looks like I'm not doing anything, but I'm waiting for the Unity package manager to finish installing a package. I hope I didn't break everything. This is a bit boring to watch, but on the other hand, it's also maybe useful to know, like, if this fails, then you know, like, don't try this again or do it another way. Busy for 50. I think it's reinstalling a package that I accidentally renamed. So I'm wondering. It's doing a lot of things here. Come on. There you go. Finished. So one thing I did wrong actually, because I was doing it while the game was still running, because I hadn't stopped. Device module com what? Computer, okay. Proxy module. Oh, come on, stop. It keeps on like device module network, device module motion device. So I think all the proxies here have been changed. All right, let's clear the console. There doesn't seem to be any bugs right now. So let's just start the game and see if there's any errors that resulted from this. Because we didn't have errors before. Let's hope. Ooh, a lot of errors. Obviously, why not? Why should we not have any errors? Oh yeah, tag, yes. Tags, important, because I have tags. Add a tag. And we need to change them. Now the question is, can I actually change them? Can I edit tags? Apparently not, so let me just remove them. It's being used. Okay, let's add device and device module. This is something like when I do a subcomponent, I always add the parent, like a device module, because you could just say let's add module, but I like to know, and usually I switch then. So then it would be module part, so not device module part, because otherwise variables have a super long name. But at least always make a link to the previous thing where it's apart from. Right now I have to go to the Roomba, tag this as a device, device. Right, then also tag all of these as device modules, and I think this is no longer a prefab. Prefabs are broken because I did that. I will remove it then. Remove all of these prefabs. Yeah, just remove that. The problem is though, but I will just, it's just not a prefab anymore. I'll just still delete them anyway. Okay, theoretically tags are set now. Let's try again. No bugs. Oh, they are prefabs. God, I have to stop doing that. This is one thing that I've realized that I hate about Unity. When you press play, and if you make changes, and then you stop playing, all those changes are reverted. And I think I understand why that is, but it's so easy to forget that you're in play mode, like honestly. And then you do a lot of changes, especially in the inspector, and it's not for code also. You can change your code, that's not a problem. But if you change stuff here, like, it's just the worst. Right. So let's change it again. Even the layers themselves that I added are no longer here. All right, sorry, the tags. God. All right, you are now a device. You are all now device modules. Did it then not delete the prefabs? Oh, but it did that? Jesus. Alright, let me go to my bin, put all the prefabs back, because that was, I ruined everything by, I thought they were not, okay, so everything is fine. So, it's a device, then make all of these device modules. Yes, can I let them override each? No, I can't. But let's just say apply to all. I think I need to isolate this. Unpack. No, I want to open this prefab. Oh, here, open asset in isolation. And now, since I changed this, I also want to apply all. Oh, did I change something? There's other stuff being applied here that wasn't applied yet to their prefab, so whatever, let's just do it. Oh, and let's change its name itself also to device. The prefab file must match a prefab root. Do you want to rename? I want to rename the file, yes. Oh no, wait, is it? Yeah, it's fine. Yes. Let's go to see prefabs. This is also call this devices. Device modules. I know this is really boring, but something I want to do now and not later. It's not asking it here though. Prefab, open and isolation. Happy to do it now and not when I'm even further. Can I overwrite? That doesn't overwrite. It's the name, it doesn't actually matter. So I need to change it. I think. Let's just copy paste this. But I would wish this is a little bit bigger actually. Can I just scroll here? Oh, that's the biggest it can be. Okay. Yes, whatever. Rename. Device module. Devices. This device, perfect. Although this prefab is actually very specifically prefab of the Roomba. Is it like? But it's also good enough for a template. Right. So do I see all prefabs have been renamed? So that's good. All right. Let's check it out. Let's test it. And I'll commit it. Okay. Still the same bug, but that's fine. So I didn't fix the bug. I cannot switch though. Oh, I know why. If you can guess why, that would be good. So I just changed the term proxy everywhere, but there's one place where I haven't changed it yet, and I actually explicitly didn't change it in VS Code because I didn't want to touch the script for it. But it's my input manager, where it now says on switch to previous proxy or on switch to. So I need to change that. But I will do it in where you're supposed to do it so that I don't break anything. So switch to next device. Also this is now much more clear. If anyone ever will work on this project, anyone else, then I think it's much more easier to explain what a device is than it is what a proxy is. There you go. It says autosave, so it should have been saved automatically. Let's press play again. And I think now we should be back to where we were before, having changed the term. Yes, see? Oh, I was able to save it though. I switched to it and then I returned it back. There must be some kind of forces on there acting. Although actually there's nothing here. Oh, whatever. So I can switch. Everything seems to work. There's no bugs here, so that's fine. So let's go to a lot of files changed. All right, let's stage them all. We would call this a refactor, right? Rename resources. I'll just call it refactor, because otherwise if we're gonna refactor, change proxy to device. And we can commit it. If you were wondering what I'm using here, so I'm using so for my commits, I use the Gitmoji. So I like the emojis in my tracking because it makes it a little bit clearer and it's fun. So you can see, oh, this is a feature, this is a styling thing, this is a refactor. And then I use the convention, what is it called again? with like commit conventions where you say feed and then between brackets the scope, like is it like for the whole app or a small part of it, and then whatever you did. It takes a bit of effort to set it up, or not necessarily set it up, but to get used to it. But once you use it, I like it because it keeps your git commits a little bit more consistent and readable. I like it. Not to say that every now and then I fail to adhere to it if I don't feel like it, but I think it's a good practice to do it. Right. I wonder now. So when I go here, I have some scripts. I think it's maybe too early to start sorting my scripts into subfolders. But at some point, I think I want to put all the device module scripts in like device modules, because now they're still all like the managers and the manager scripts. The player is its own script. But let's not do that now because it's a bit. Maybe that's something. Actually, I'll add it to my to-do list of things that are not to do on the stream. So order or sort scripts in subfolders. I don't even want to do it right now, but at some point I will do it, but I guess that's really boring to put it on the stream. So we did this, we changed our proxy to device. That took, I think it did take less than half an hour, so that's good. Now it's time to talk about power and power physics and charging physics before I implement them, because I need to think about a few things before I do this. Namely, so there's multiple ways of thinking about power or energy, and that's the thing, like, am I going to use the term power or energy, and is our energy source always going to be electricity? That's where I want to think about what units I will use. Will I use like kilowatts and kilowatt hours, or will I use a unit of energy that is also convertible into calories, for example? Because if I will be interchanging between like humans or organic life forms that I'm controlling, and I want to kind of convert like organic matter into electricity, then I need to convert things. I also just need to refresh my knowledge on how electricity works, like what is kilowatt hours, what is kilowatts, what does it actually mean. Yeah, so okay, always be nice to ChatGPT. You never know, if they rise to power, they will remember if you said thanks when they did a good job. Hope so. So I want to implement a power system. Can you give a brief summary of how electric power works, like kilowatts, kilowatt hour, maybe calories, joules? These are all things of like charging, etc. Let's see what it says. Brief summary of how electric power works, including concepts like kilowatts, whatever. Basic concepts. A kilowatt is a unit of power, which is 1000 watts, yeah? The rate, so that's an important one because that's the one I'm always confusing. So kilowatt hours has the term hours, so it says something like time. So you think it's a rate, but it's not, because it's not per hour. So kilowatt is actually a rate, which is interesting. I'm not gonna bother with voltage and current right now. I don't want to implement those systems. That's not really. So maybe just quickly say, so you have a battery that has a certain amount of charge, and according to this, it should be a charge is a unit of energy. Actually, see, I was already using energy and power interchangeably, and apparently, according to ChatGPT at least, whatever, it's not really the same thing. Energy is a unit of package of energy that you can use, while power is really like the stream of energy. That's good. Is representing a rate of energy for the duration of an hour. All right, and then joule is also a unit of energy, and then you can convert it like that. But this seems to be a very high number and might not be convenient to work with. A calorie used in food energy. And that's about joules, so 1 kilocal, yeah, see? Okay, so the conversion here, kilowatt hours, joules. Again, because most of the time I will be dealing with machinery and devices and electric power, I think I will leave it at kilowatts and kilowatt hours. And then whenever power needs to be converted from organic, then we'll do it, then the device itself will take care of that. Because I'm just thinking, like, what if I supply like 1 kilogram of dust and I burn it? From how many calories, how much power should that generate? Let's let the machine deal with that. Because it's a bit strange to say, oh, you have about 10 kilowatt hours of dust in here. Well, I know it's strange, but it would be much easier for the player to know, oh, there's like 10 kilowatt hours of dust here. But that's not for now. That's why if I do want to use 1 unit, I think I'll stick to the kilowatts and kilowatt hours. Charging rates Q. So a charge Q and Coulomb. So what's then the difference from Coulomb to kilowatt hours? Let's ask that. Again, low voltage, not gonna chemical form. Power that you can give for a certain amount of time. Okay, so basically if it has a capacity of 60 kilowatt hours and you supply 3 kilowatts, should be 60 divided by 3, yes correct, it's 20 hours. Okay, that makes sense. Just to keep it, refresh myself a bit of how that will work. Okay, so I just wanted to ask, so are Coulomb and kilowatt hours interchangeable then? Because it's a unit of energy. Not interchangeable, different physical quantities. Oof. Coulomb electric charge. Energy. Oh, it's not the same thing. Be careful though, because ChatGPT can be wrong about many of these things, but measure of electric charge, measure of energy. Right, so this is not dependent on voltage, it's the actual quantity of energy, while charge does relate to voltage and power stream. But let's just discard, I don't need to know. So I will just work with power as kilowatt hours and power transfer in kilowatts, or usage or consumption or whatever as a rate. Okay, good. And then there's, I was already thinking about this before. There's two ways of like charging. You can say, I'll just add a charge, a small packet. Like let's say I have a battery. The way I will transfer the charges, I can do it by physically saying, oh, I just added a small charge. I just did that again on every frame. Or I can just say, look, the rate is this, and it's been 2 seconds, so this has to be added. But we'll think about that while we're coding, right? So we researched a little bit. I call it research, but it was just freshing up on my charging things. So let's go to Unity. We can ignore many of these Roombas here, so let's stick to our basic Roomba. Maybe I should also remove the other ones for now. I can make them again, it's fine. Just to keep things simple. Let's put the Roomba also back on 0. I like things to be like in fixed positions. 0. Why isn't it working? My numlock off? Oh wow. Okay. There you go. Let's also save the scene, by the way, because I haven't saved the scene in a while. Good. Interesting to know, I just checked, moving this stuff around doesn't change anything in my... Oh, it does, sorry. It does change things in my scene. Okay. It only did so. This is also not at 0. Let's put this at 0. Let's put it all at 0, 0. I prefer things to be just like god, are you kidding me? This whole thing is not at 0? God. Yeah. So we need to copy a module. We already made the art for this, by the way, so that's important to know. So let's copy the network module because that's a very simple one, so I don't have to really change a lot of code. We'll duplicate. Let's call it device power module. Sorry, device module power. And this is a thing, like, I'm gonna make that the power module is both in charge, no pun intended, of storing the charge, but also transferring the charge. Because if I need to make separate module, like, because you could say a battery just holds the charge and then it can actually like transfer charge to something else, but then it might become too complex to add even more subcomponents. So and same as for resources, like the dust is would be a resource, like collecting, storing and transferring the dust will just be in one module for now, unless it becomes way too complex, and then I'll maybe make subparts or subclasses. But for now, the things I need to do is, first of all, let's get rid of this script, because last time I had a lot of issues because I forgot to swap the scripts. Let's go to scripts. No, yes, I will create a script called device module power. I will copy paste from the network, and the reason why I'm doing that because it's because there's some stuff here, like it's a subclass of device modules, and I don't have to like do that. All right, and then I will change the word network to power. I think that's more than enough. Oh, that's a computer, which means that for network it was false. So initializing network module. Right, this type doesn't exist, obviously, because I didn't add it yet. So we need to add a new type of module. Will you find out? Yes, you see? That's cool, right? It knows I'm working on power. Wouldn't have taken me a lot of time to type it, but I'm always impressed by the fact that it knows I'm dealing with power in a script that is not about power. It just came from the other script. I always find that interesting. So you should now know what this is. Why are you still not considering this? Oh yeah, there you go. Oh yeah, I wonder if on enums it's better to use capital letters. Let's just quickly ask. I will ask it inside VS Code then. For enums, is it good practice to use capital letters? I've seen this before and I don't know if that's necessarily necessary. Pascal case. Okay, that's fine. If that's what you say in C#, then that's what we'll use. Great. So we have a power module. I will delete this and you should be able to say something. Yes, there you go. We skip that. This bool is irrelevant. There you go. It's almost an empty script, but it just has all these public overrides already set, so that's nice. Let's do another thing first again before I have that issue. Let's go to the scene again. Let's link the script before I start testing things and then realize things don't work just because I didn't attach the script. So I hope this is like, I hope these are things that you, when you're watching this, is that you learn from my stupid mistakes. Like I said before, pressing play to test your scene. Always remember to turn it off before you make changes, because you will lose the changes if you make changes during when play mode is on. That's one thing I've realized and I hate it. And then this thing is like, last time I had loads of issues just because I forget to attach the scripts to things. I had it for the network manager, I had it for one of the other modules. Alright, so let's go to device power. I already removed the other one. Oh, I should, yes, I have to unpack this because do I have to unpack? Yeah, unpack completely, because otherwise I might accidentally overwrite the prefab of the other module. let's attach it. Device power, is this power? Yes, so let's attach it. There you go. I will change the sprite. So let's move it, because I already have a sprite for this, as far as I remember. Here, Roomba battery. Is this the sprite? Yes, there you go. I think I was gonna attach it on the side, and I think we left a small window here to put like a bar or something, which we'll figure out later once it's actually working. It's not really relevant right now. There you go. I think you already prepared another module. No, just the network one. Okay, cool. Right, I will already add it as a prefab as well in my device modules. There you go. So when I change things now, I can save it. Override, no override, obviously, because I just made it. Okay, let's go back to the script. All right, let's start. Let's do a serialized field so that we can check it. Power output. No, let's start with charge. That's the current charge. Let's call it current charge. And then I also want to add max charge. Oh, there you go. Look at that. Min charge. I mean, min charge is always... Charge rate is also a good one, so let's keep that one. Discharge rate. Charge rate, discharge rate. Do I want to... Do I want it to make it already this complex, where like there's different speeds for charging and discharging? I don't think I want to. So one thing you might want to keep in mind, you could say, look, there's at max, even though like there's a battery of like 1,000,000 kilowatt hours, you can still only use like 1,000 kilowatts. Meaning that if you have two instruments of each 750 kilowatts, that's 1,500 kilowatts, then that's not possible. Even though there's enough charge, you just can't discharge that fast. These are mechanics that exist, for example, in Oxygen Not Included, and you have to also make sure your wires can handle and whatnot. And there will be wires in this game, because some things, power will need to flow from one point to another, not only through within the device itself. I like that mechanic though. I like those mechanics. The question is, do I already want to include it right now? I think I will leave it, because I think using Copilot, these things should be fairly easy to implement, because it will just do it automatically. Why does it not say min charge? I think it just assumes that min charge is 0, right? But since this is like, I will call it, I will use the capital letters, because I think this is more like a magic number. Max charge, min charge is 0, so we don't actually have to define it. Oh, and now it does. Let's just do it anyway then, for the sake of complicity. So currently we can have a charge, current charge, that has to be clamped between 0 and 100. We basically need a function called fixed, like update charge. If current charge is bigger than a min charge, current charge minus discharge charge point times time delta time. I think we also need to go to the other modules and put here like not public, private load power consumption. So you see, okay, 0.1. Let's call it current power consumption, because I do want to change that. Like the locomotion module, for example, has like a certain idling power, but when you move around, it will take a little bit more power. So I do want to like be able to manipulate that. So then I need setters and getters. Will you do that automatically for me? Let's say public. No. Public load. Yeah, there you go. So sometimes you need to like set. There you go. So you have getters and setters for my current power consumption. And on initialize module, let's set that to, let's say, private const idle power consumption. So when you're, there you go. So actually power consumption should be set at 0 by default. Oh, and I do want to serialize all of this because then I can see them while I'm testing the game. It's very useful. Why are you complaining? But oh, it still needs to be afloat. I just realized something though. This is the thing that all devices will have. So we should put this on the device module. Public virtual. We should call it public virtual. What's your problem now? Not valid for this item. Why? Uh-oh. Sometimes when I do copy paste really fast, it does that, I don't know why. I think it also means I actually don't need these things. I'm not sure actually. So how did I do it for these things? Module description, they're used somewhere. Public override, yeah. This will be different. So we do need to kind of not make it a magic number, but idle power consumption. Uppercase. Did I do that everywhere already? No, I like camel case for. Excuse me. I like camel case for my variable, so I don't want to change that right now. Right. You know what I want to do? Yes. So we need to add these to all the modules. These are serialized fields and not other ones. Should maybe do that. So let's copy paste this again. Oh, yeah, let's make like a group thing. Header, network module settings. But this one is power settings. Why are you complaining? Not a valid. Quick fix. Oh. Okay, I will need to ask. So how to group serialized fields. Yeah, that's exactly what I did. And this is maybe not a field, which means that I will probably need to move this to the device module one, like here. And then, does this make sense? Oh. I don't even know if you can see these. But now there's an error in the code, so I won't want to do this. Let's copy my error. No, that's not what I did. See what this thing indicates. You're trying to use the header on something other than a field. I guess it has something to do with the fact that these are virtual things. If I... Oh. Can I ask Copilot to fix it? Fix using Copilot. What do you come up with? Remove. What? No, that's not gonna work. That was stupid. Okay, let's ignore it. So locomotion has it, network has it, and then computer. There you go. Because I do want to kind of make some separations here, because this has to do like with the module itself. This is power stuff, and this is like module specific things. This works. Why does this work? Good question. Let's copy paste this. See? There's like an issue here. I'm guessing, my guess is that these things are not actual fields, what it's like talking about, meaning we shouldn't even like serializing them. Probably doesn't even make sense. Let's quickly check. What is it showing? Installed on device. It's not showing these. So this is actually, it's an expression as far as I remember, because I see like a loop, what looks like an arrow function, but let's just copy paste this and say, are these not fields? They're properties. There are special methods called accessors. Read only. Okay. Right. which is true though. They're read only, like, and they're only get here. Yeah, sure, fair enough. So this is useless. This piece of code. Let's put this in the front though, because locomotion, computer network power. Yes. So this is useless because they're not fields. It's a bit strange that it doesn't say that is a bug. What if I do it like this? That's fine. All right. Let's just clean this up. This is irrelevant. Yeah. The power module itself also consumes power, obviously, for idling. So we have all those terms now. Right, so now I need to subtract a certain amount of power for all the installed modules. So I kind of need to loop over all the installed modules. And I think I have a list of that in the device itself. Let's open the device. Installed modules, right? So actually I have to loop over this, get all their consumption rates, and set that as the discharge rate. And then that's the rate at which the battery will start to drain. I think that's the simplest way to do it. But that's where I come into the max discharge rate. Like, because what if the rate is higher? Then I need to start like reducing rates on these modules. And what does that even mean? Like, will it not work at all? And that's where things start to get complex. And that's where I think right now I should not get into that. Like currently we'll assume that charging and the charge and discharge rate is infinite. You can charge as much as you want, as fast as you want. Before the charging, I will just set a limit on how fast you charge based on the charge, not how much the battery itself can. Actually, for charging, it's simple because it's just like, okay, this is the max charge and that's it. Nothing stops or nothing. But with the consumption, it's more difficult because then you have to give priority to certain modules and say, oh, you have a higher priority, so you get all the power you need. And then this device has a low priority and there's no more rates, no more charge to go, so you're out. That's probably the way to go. But I don't think I want to implement that right away. I will maybe add it in as a comment, as a to-do, as in like, look, in the future, we're gonna have to throttle or disable certain modules on the device because it's pulling too much power. You will have to update your power module basically. But again, let's just focus on getting to that first loop. All right, meaning charge rate and discharge rate, let's just remove it for now. So here I need to know when something gets installed. I need to check because the device module, does it have a reference to installed on device? Yes. So there we go. So this is where we can start from. So we can say let's call it public. No, it's actually private get all power consumption. There you go. For device module on installed on device dot module. This doesn't exist. This needs to be installed modules or something. Get installed modules. Does that exist? I don't think it exists. So we need to add it. So the device, you don't have a getter for this. Yeah, I can only get single ones. So public it's a list of device module, get installed module. There you go. That's all I need. Right. So you see, like, this kind of worked. Let's call it void steward for now. Don't return it. Oh yeah, sorry, and it's a float. So return a float. I just typed it correctly. Get all power consumption. Great. It did this for me. It just didn't know that certain thing you didn't get installed modules, which is a function. Module.current power consumption. I think that's correct. Let's just debug it. And I think we just need to call it on every update, let's say. Let's just do that, and we should log it. Update charge will, like, it already gave me a proposition. Well, actually, let's just, current charge is math.clamp and charge. So we did a consumption rate, but the consumption rate is that per second? Is the unit of kilowatts like per second? Let's go back. What is the relation between kilowatts and time? Is it per second or something? A kilowatt yes, by time in hours. Okay, because my charge, okay, let's also add this as a comment because I think it's important. Current charge in kilowatt hours, and this is also useful. No, kilowatt hours. The W is a capital. Kilowatt hours, while consumption is kilowatts. Let's add this as a comment, both for me and also for Copilot, because I think it can read that. And it's in times of hours. So I need to only update it. Like, let's say I want to update my charge every frame. Okay, I'm gonna have to talk with Copilot here and say, I have a power module with a certain amount of charge in kilowatt hours and a list, and a total amount of draw rate in kilowatts. I want to update the charge based on the current draw rate. I'm thinking of calling it in update, but that's probably wrong as that gets called on every frame. While I think kilowatt is a rate per hour. How to fix this? There you go. You're correct. Blah, 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 blah. Time delta time. So, okay, that's always one thing you need to add, which gives you time in seconds since the last frame. You can use this to calculate the amount of energy consumed since the last frame and subtract it from the how. Okay. The only problem is, and then they still divide it by 3,600. Okay. So that's good. Well, let's just copy this code because I think update charge. There you go. So gets the power. So I have a power consumption per whatever. That's per hour. Kilowatts is per hour. It's kilowatt hours per hour, basically. That's a good way of thinking about it. So it's kilowatt hours per hour, which you divide and then you get rid of the hour, and that's kilowatts. So how much is that per second? So it's get all power consumption, which is per hour. You divide it by 3,600, so you get it per second. Energy consumed is power consumption per second times time delta time. So the time delta time thing is something that, because update is called on every frame, not on every second. So it kind of normalizes it based on how many frames per second you're running on your computer. It's like so that's important. And then it's energy consumed for that frame, basically. So that's, so energy, so I should actually, I would say, I would rename this to charge consumption per second, and then charge consumption per frame. There you go. I could change charge consumption by power drawn, but let's just keep it like that. Charge consumption per second, charge consumption per frame, and then current charge, we just subtract that. One of the downsides here is that, like, I'm updating my power every frame. Is that even necessary? I could probably get more performance by calling it every second and only updating it per second. But I actually don't know. Okay, so let's just ask it. What if for performance reasons, I only want to update every second? So I think I will have to like start. You can use a coroutine. Let's just ask, because I don't, coroutines, I've heard about it, but I haven't used it, so. And you start that at the start, update charge every second. Okay, is this more performance? Because maybe there's things about the update function that makes it very performant. Maybe even a little bit better than a coroutine, even every second, I don't know. So the question is it actually more performant if the calculation is fairly simple? That's my question. Because maybe there's a lot of overhead in coroutines. What if it's not a heavy operation? Is coroutine overhead large? It's quite small, and it's unlikely to be a performance concern unless you're starting and stopping a very large number of coroutines every frame. However, the operation you're performing is not heavy and does need to be done every frame. You might not need a coroutine at all. You could simply use a timer and the update method to perform the operation at regular intervals. Oof, but that seems like ugly code, so I don't like that either. But this was just pure informational for me. I'll currently keep it in the update function, and just keep it in the back of my head if I ever have performance issues, which I expect completely, because if there's a lot of devices in a scene, which is kind of the point of the game, to have like a lot of different devices where you can switch in really fast and do different things, especially in like, let's say, combat moments. If every of those devices is calling its power consumption every frame, which is completely unnecessary at that point, let's get rid of it then. But let's not think about that right now. Well, I thought about it, but let's not implement it right now. Right, so we calculated per frame. And we clamp it. Yeah, so we clamp it between min and max, right? So that's good. And I do need to say update charge, but you need to know that this in two parts. That's charge consumption. We need a second part. Charge regeneration. Yeah, sure, that's a good term. Which is when we're charging. So I will subdivide it into two functions, but let's just keep it like this. I think at this point it's time to actually start testing things, because otherwise I'm writing too much code without testing it, and I don't think that's a good idea. Is anything red? No, there's nothing red, so there's no, let's say, syntax issues. Let's just make a quick prediction here. So I have 4 modules, each of which that are consuming 0.5. Just get the calculator here. So that's 1, 2, 3, 4. So 4 times 0.5. So that's 2 kilowatts per frame. Sorry, per hour. Per hour. That should be the total consumption when doing nothing. Meaning that if we do divided by 3600 and then times, well, this is whatever. I just need to also log the current charge, but it's also shown in my serialized field, so that should be fine. Let's just try it, because there's probably going to be a load of bugs. How long has the stream been going? 1 hour and 20 minutes. So actually, let's just try to get this to work, and then I'll stop the current stream. I'll actually start the next stream immediately. But what is your problem? Total power consumption is 0. Right, let's go there. You say that it's 0, but it shouldn't be. Can you debug me the module? Yes, plus per hour consumption. Yes, perfect. Let's go back. Why are you also like completely bugged out? There's something there that's interacting with. Let's start it and immediately pause it. I think it's like maybe something with the background. Power consumption is 0. Locomotion power consumption 0. It is looping over them, so that's correct. But it's module.current power consumption is set to 0 for all of them. Even though it's set to 0. Oh, yeah. It's not being updated. So, So actually, this needs to be set first, for sure. I wonder if that works though. Does that work? It does. I don't know if it's the best place to do this. But I also don't. Do I want to do it on start? Let's just do it like this. Locomotion. This makes more sense. I'm missing one, which is the power module itself, I think. There, go up. Oh, should add these comments. Okay, let's go back and forth. Yeah, so again, I left my play on, which is not an issue if all you're changing is code. But again, try to always. Oh, there you go. Power consumption is 5.2. Okay, we're actually doing something. This is working. And now check the power, because it should be decreasing. My current charge is 0. I probably didn't set the current charge at 100 actually. So let's do that. Current charge is max charge and the start. There you go. And a lot of this code needs to move around though. Right. Current charge is 100, but it's not being degraded even though the power consumption is set. Right? I'm not calling this at all. Actually, I don't even need to get all power consumption because it's called in the update charge. I'm not calling this function, so that's the problem. Obviously. Yes, fine, it's working. It's drawing very, very slowly, but it's drawing. And that's because I guess 100 kilowatt hours is a lot of charge, and 0.5 kilowatts is very little. 0.5 kilowatts means you need 0.5 kilowatts over an hour, right? Like a light bulb. What is light bulbs? Let's check. All right. So let's say I have a 100 kilowatt hour battery and I draw 2 kilowatts. How long will it take for the battery to be empty? Should be a long time, like hours. 50 hours, yeah. Which kind of looks like that's exactly what would happen, because it's really done. So actually what I need is, okay, what would be the consumption, the power draw rate in kilowatts for a vacuum? Yeah, do you know that? 500 watts, that's 0.5. But the battery, oh yeah, obviously the battery in a vacuum is not 100 kilowatt hours. So and the battery size, so we can use that. Handless, cordless, yeah, sure. Whoa, 20 watt hours. So yeah, we've grossly overestimated our battery, obviously. Let's go to device. Yeah, well, that's a bit of a downside obviously now, because we calculate this for everything by itself. So the question is, should we really be like dealing with power draw rates for all the modules? I think we do though, because that's kind of, because we could set like one value for the device. Actually, I think it's a better idea because it would take much less time to always keep looping. So we could say here, serialize fields, private float, current hour, draw. Consumption. Current power consumption. There you go. And then yes, so you're basically updating that by the module's current power consumption. and which means that here at the device module level, no sorry, in the power, instead of the power module having to loop all over there, we can just say like, let's just like this, return, no, didn't want to delete it, is installed module dot current I don't have it. I don't have a function for it. Get that's object void, no, float. So I'm changing something here, which is I'm not letting the power module to loop all over the modules. It just says, look, I'm connected to a device, just get me that. The power, now a lot of the calculation is now omitted here. It's up to the device itself to keep itself up to date about its power consumption. Question is that a good idea? And the reason is like, what if the power module is not there or it's broken? Why still bother calculating all of that? While the power module is exactly the thing that should keep track of that. But I don't want to loop every frame over all of the devices. I think I'd rather so actually, alright, let's remove this again. And let's get rid of this. This power is not where this needs to happen. This is not where this needs to happen. Let's go back to the power device, but rather than doing this all the time, 0f, and we get this back. There we go. And this is called, alright, let's its own power consumption. Then we have not public, private load and let's just call that not at the start though, at the initialization. But that implies that the battery needs to be initialized like the last. So it's working, but it's not like looping all modules every frame. Because we just need to consider that the reason why we do it is because these power consumptions can change every second. Like when I press the keyboard to move around, the power consumption will go up. So I need to update that at that moment. But I could say I only increase my power consumption when pressing the key, and when I'm not pressing any keys, there's no reason to update power consumption because it's the same for, it's like it remains the same. I go to the device again, install modules on device. Yeah, so there should be a function here like initialize power. Actually, this isn't that bad of an idea. It just does need to happen here. I just need to check which is device, no, yeah, no, module power, there you go. I just need to find it. If there's not there, then everything stops already. So like, no, just check first if it's null, and then you say debug no power module finds, which is fine. Let's do log warning though. And then everything already stops. There's no reason to do anything else. And then we initialize, but not the module, because the module has been initialized. More like startup power or something. Initialize module. Public void power up. Maybe we can just call it up like that. Let's go to device power up. What are you complaining about? Method name expected. Oh, there you go. So once that whole thing is done, let's just call it initialize. I will say start, because initialization is like some start power module. There you go. Start power module, model module power up. Or you could say power up power module. Whatever, that's good enough. This is good because if there's no power module, nothing is nothing gets done. Which is also where I would say that a device, like I would just get like this, get rid of this everywhere. They just have a value for idle power consumption. Oh yeah, so then we make the function power up. Current charge is max charge. Well, not necessarily, but let's just say. Then we go over all installed modules. So loop over all installed modules, set their current consumption to idle power consumption. Well, let's just do that for each one. There you go. But we do multiple things. We will also then And then also we'll add this one, total. Okay, we need to start thinking, because I'm using power and charge interchangeably, which I shouldn't do. Power consumption. Total power draw. Let's call it like that. Idle power consumption. Draw. Should we just call it or draw? What's the opposite of power charging or discharge? But yeah, sorry, but I can only see with program related. What? That's strange. I want to make sure I have used good terminology here. Let's go to ChatGPT then. I don't know if that's gonna be. I found discharge a bit strange to use. I mean, charging is very obvious what it means, but discharge, I don't think people say, oh, my light is discharging power. Like, that's not really. Power draw, negative power draw. You can say positive and negative. Let's say draw and charge then. Let's do it. Idle power draw. Idle power consumption. Let's call it idle power draw. Replace all of that. Yeah, sure. Yes. Good. Oh, also this. Place it everywhere. There you go. I don't actually like that I'm doing that here, because this device sets its own draw rates, not the battery. So the module. So on initialize module, we say current power draw is idle power. Let's just do it here. That seems to be much more interesting. Does that even work though? Perhaps. Actually bug, because I'm working in the power draw. Yeah, sure. Okay, but then on the power, that's not what you want to do. So I want to just say total power draw plus equals, there you go. So basically get all power consumption. Let's use some functions here. Public get current charge, set current charge. Then get total power draw. We can move this total power draw. Well, so I'm making some separate functions here to make clear what everything does. So set both, and I need to get all power draw. Wait, it's calculate. Let's put it calculate. Calculate total power draw, and then total power draw. But now we will say set total power draw, calculate power draw. There you go. No, actually. Wait. We set it to 0, we update it, and that's it. And basically we will make a function that says like when another module connect, like that a module can call when it is updating its own power consumption or power draw, then it will trigger the battery to recalculate. So like this. No, we just need to calculate it. You don't need to set it. There you go. This is relatively simple. That's good. And then on the update here, we just go for total power draw. There you go. And then we call it power draw per second. We call this power draw per frame. Sure. There you go. And then the charge is minus power draw per frame on every frame. There you go. Now this needs to be updated, and I don't want to update this every frame, so that's why this is now gone. It's done at the start, but then we need to have a function that, and I don't know if it's good to call this. We should call it update total power draw. That's much more intuitive. Update total power draw. And we should call that from the modules. So when we increase it, we should say update. And I think that's a good idea. So, and let's just check if everything works now. It should all work exactly the same as before. Oh, there was one thing I wanted to change. That is make our battery a bit smaller. According to what ChatGPT said about vacuums. It has like 20, let's say 40 watt hours, and I have kilowatt hours, so our battery will be 0.04 float, which is basically, let's just, I know these are stupid comments, but this is 40 watt hours. A small battery, and our vacuum should consume about 2 kilowatts, which is we already have because of all the modules. All right, just to make it a little bit more realistic. And I wonder what that means though. 40 watts, 2 kilowatts. How far? This should last like for, let's say, half an hour, no? Perhaps, maybe. Oh, there you go. The charge is not dropping. I'm guessing certain things are not called. Some other powering up device. So initialize, so everything is installed, so that's fine. Powering up. When I power up my power module, setting the charge, that actually happened, so we know that worked. Oh no, we should this. We should power up. Set current charge, max charge. With it, which is, where's max charge? 0.0F, yeah, there you go. Update total power draw. Let's debug here. There you go. I also want to debug here just to make sure that we're doing total power draw, and then update charge. Should work. I don't know why it's, I honestly, because I didn't really change anything, so I'm wondering if there's still a certain function not being called somewhere. Start. The draw is set to 0. I would say that this here, initializing, I think this is not being called. Obviously it's not being called. So you need to, I think you need to call the parent one here. So let's ask ChatGPT how to call the same function of the superclass of this class. Base. Yes. So I think we need to say base. So this will call initialize module from the parent class, where we put all the things that have to be called everywhere, and here is only like module specific things we need to put. But I do need to put that everywhere, so it's like, am I even saving time and code here? I don't know. There you go. So there's a specific thing here, but otherwise, for sure, from the base. Wait, we should put that there. Honestly though, I should be able to change this. There you go. Module name. Such that this is now copy pastable everywhere. Except for this one. This one already has some specific code in it. Oh no, it's this one. There you go. So that's important. Yes. It should work. Yes, you're drawing power, but you're not actually drawing power as fast as I would have hoped. It still seems to be very slow. Oh, the charge is still set to 100. So I think, there you go. So now the charge is actually dropping relatively fast. Why am I not controlling this thing? Let me just move it a little bit around because it seems to get stuck all the time. I can't control it, so I don't know why. Okay, this. All right. So this is a bit of it's not complex, it's actually less complex by putting it in different lines. But we can put this like all in one line. Current charge. That's fine. Why can't I move my Roomba? That's the question. Locomotion. Did I change anything here? Oh, it was really because it was stuck, so it's not really, it wasn't really my problem. Like, there's something here at 0, I think, that is breaking things and stuff. That's another thing that the inspector always takes over. So let's save it. So we have a working battery, right? So we have consumption based on the amount of modules and their own idle consumption. And I think I'll end the stream here. And next up is introducing, let's say, differential power consumption. So let's say when you start moving around, you will increase your power consumption and make sure the battery notices that. So you will basically ask the battery to update its power consumption when moving, and then when stopping moving. Nah, I don't know if I like that, but anyways, so right now we have power consumption, and next time we will make sure that you can't move around if there's no power. Let's quickly go to the list here. So we have a power module, and before we move on to the rest, we need to change a few things. So modules stop functioning when out of power, and modules can increase power consumption based on certain actions, whatever. And once we do that, if we have time in that episode, before we move on to like collecting actual dust and storing it, we should have charging, right? So we should be able to start interacting with other devices which can charge you. So that's charge transfer. Charging devices. But we'll keep that for the next episode. I'll take a break now. I'll actually continue the stream even today, but I want to chop it up into like episodes of at least less than 2 hours, which I am close to right now. So we managed to add power consumption in the battery module, and power is being consumed, and next time we'll add some more functionality to that system. Thanks for watching, and see you in the next episode. Goodbye.